An Euler path is a path that passes through each edge of a graph exactly once. Okay? So notice this word here, it's not Euler, it's Euler. Okay? And what I want you to remember here is that Euler goes with edge. An Euler path has to go through every edge. And as you can imagine, an Euler circuit goes through every edge and begins and ends at the same place. So this is kind of like those games that you used to play. Here's a picture. Try to go through all of the edges, and you only want to go through each edge exactly once. And then you want to play the game and try to go through it and start and end at the same place. All right. Now, the answers I'm going to come up with aren't unique. There's many Euler paths usually in a picture, and there's usually more than one way to find an Euler circuit. So I'm just going to randomly start on this one. And to find an Euler path on this one, well, Euler starts with E, so let's start at E. So I randomly chose E. Okay. Now, what you're going to want to do here is remember where you're going. So let's start at E. Now, notice from E, I could go to C, B, or D. Oh, I'm going to go to C. So from E to C, and what I'm going to do for myself is I'm going to purple that in right there, so I know I've traveled that edge and I can't travel that edge again. Now from C, I could go to D, B, or A, so I'm going to go up and pick A. And again, I'm just traveling around here. Are you always going to get them on the first try? No, but like I said, it's kind of like a game. And when can you ever say that about your math problems? Okay, well from A, hopefully you realize there's only one way to go. From A, you have to go to B. All right, from B, I could go to D, to E, or to C. I don't want to go to E because that would close that up, right? Okay, well, let me go to C. B to C. All right, now from C, kind of stuck here, I gotta go to D because remember I can only travel an edge once. Well, from D, let's go back to B. Let's cover this edge. And now I think we're home free. From B, go to E. And from E, go to D. And that's an Euler path because notice I went through each edge once. And I had to follow them in sequential order. And notice I wrote out my vertices in order. And that's usually what you do. You just write the letter of your vertice in the order you traveled. Okay? And again, this is not the only one. There's more than one Euler path. But that's the one I came up with on this one. Alright, so on this one I want to come up with an Euler circuit. And in an Euler circuit, I need to go through each edge and I need to end up where I started at. So wherever I start, I need to end my path there. Okay, so where do we want to start? Oh, let's start at A. Okay, so we're at A. We can go to B or C, so oh well, let's go to C. Oh, from C, let's go to F. From F, let's go to E. To C. To B. To E, to D, to B, and finally, back to A. Notice I've covered every edge exactly once, and I started and ended at the same place. All right, so the next thing I want to go through is Euler's theorem. Euler's theorem is in your book. This is straight from your book, so if you're having trouble seeing this. And Euler's theorem says that if you have a connected graph, the following statements are true. A graph with no odd vertices, in other words, all your vertices have an even degree, will have at least one Euler path, which is also an Euler circuit. Okay? Any Euler circuit can be started at any vertex and it will end at the same vertex. Okay, so Euler path and Euler circuit if you have all even vertices, guaranteed. Okay? All right, so if all your vertices are even, you are guaranteed an Euler path, and in other words, you could also find an Euler circuit, so even better. Okay? If you have a graph that has exactly 2 odd vertices, you're going to have at least one Euler path, but no circuits. And the path must begin at one of the odd vertices and has to end at the other. So if you have exactly 2 odd vertices, all you're guaranteed is an Euler path, no Euler circuit. And the path has to begin at one odd vertice and end at the other one. If your graph has more than 2 odd vertices, you ain't going to have an Euler path nor an Euler circuit. Okay, so here's 2 pictures, and I want to know, now notice I'm not asking to find them. All I want to know is, do we have an Euler path or do we have an Euler circuit or both? So in order to do this, I'm going to look at the degree of each of my vertices. A has degree 2, because there are 2 edges there. B has degree 2. C has degree 3. There's an odd vertex. D, degree 3. There's another one, another odd one. E is degree 2, and F is degree 2. So which case is it? Case 1, 2, or 3? Case 1 was all even. That ain't true. Case 2 is exactly 2 odd vertices. We have exactly 2 odd vertices. Okay? So no Euler path. No, I'm sorry. No Euler circuit, but yes on the Euler path. Okay? Because when you have 2 odd vertices, you're going to have an Euler path, but no Euler circuit. Okay, let's look at this graph. A has degree 3, B has degree 3, C has degree 4, D has degree 3, E has degree 3. Okay, so which case is it? Case 1, 2, and 3. Case 1 is all even. Not true. Case 2, 2 odd vertices. No, that's not true, because A, B, D, and E are all odd vertices. So it's case 3, a graph with more than 2 odd vertices has no Euler path, no Euler circuit. So this has none. He's not good for us. Alright, so here's an algorithm, and again, this one is in your book if you're having trouble reading this. And it's Fleury's algorithm. And what it does is it gives us a way to figure out a path or a circuit. Okay? First step says, use Euler's theorem to determine whether an Euler path or Euler circuit exists. Okay, so let's see. Let's look at the degrees of these. A is degree 2, B is degree 4, C is degree 2. Remember, we're trying to find odd vertices because those are the bad ones, right? D, 1, 2, 3, 4, that's good. E, 1, 2, 3, 4, that's good. F, 1, 2, 3, 4. G, 1, 2. H, 1, 2, 3, 4. And I is 2. Oh, we have all even vertices. So if you remember, from all even vertices, we are going to have an Euler circuit. Okay? If a graph has no odd vertices, our example here, choose any vertex as the starting point. If the graph has exactly 2 odd vertices, choose one of the 2 odd vertices as a starting point. Okay? So since we have an Euler circuit, I can start anywhere I want. I'm going to choose to start at A. Begin to trace edges as you move through the graph. Number the edges as you trace them. Since you can't trace any edges twice in Euler paths and circuits, once an edge is traced, consider it invisible. Okay, so you've already traveled it. Okay? When faced with the choice of 2 edges to trace, if possible, choose an edge that is not a bridge. So in other words, don't disconnect your graph before you're done making your path. Okay? Continue until each edge of the entire graph has been traced once. Okay? All right, so if we can, try not to do a bridge. And looking at this picture, I think we're pretty good with bridges, right? I don't see any bridges. Okay, so let's start. I'm at A. Where do you want to go? Oh, let's go to B. So I'm going to label that one 1. And over here I'm going to write B because I went from A to B. From B, let's go to C. So I'm going to number that 2. There we go. Let's go to C. From C, notice there's only one way to go because we can't go back that way. So let's go to F. All right. Now we could keep going down around, but why don't we do this? Let's go up this path right here. So from F we went back to B. From B, only one way to go, right? Got to go to E. And notice numbering them is the same thing as when I was going over them. Okay, because now I know that edge is taken, so I can't go over it again. Okay, so now we have a whole bunch of options. From E, we can go all these different ways. Doesn't matter. Let's go this way. From E, let's go to H. From H, let's go to I. Well, from I, we have to go to F, right? And now, well, we're at F. The only way to get out is to go here. Okay. We're at E. We got to get out of E. There's only one way to get out of E. That's to go to D. Okay. Well, at this point, let me go back and pick this guy up. That's 11th. So let's go back to H. Only one way to go here. Let's go to G. Now we're stuck, right? We got to go to D and then go back to A. Notice we've created a circuit because we've started and ended at A.